There we go. Okay, so
should it show like if it shouldn't show the variables anymore, right? If it's cleared it, so
correct.
I'm not doing that.
All right, so what I typed in was use space http colon / scc-light.bu.edu / Harbaugh / behave with a capital B. I think it does need to be capital .dta. Again, I'll zoom in on that so you can see that part there. Okay. Are you trying to run like a do file?
I wanted to copy all of my commands into a do file, but it looks like you can only open one. You can't like create one. Like, do you just create it in a text editor?
What I used to always do is type it in text, copy it into it, and then because a do file is technically just a text file.
Yeah.
Right.
Because it wants
but,
to. Oh, yeah.
Yeah, I'm not sure. It seems that you should be able to save the stuff.
You think so?
Yeah, but I'm not sure how it does the saving. So.
Okay.
Yeah.
I will say that's text.
Okay. All right, so so I brought in this file, and this has the following variables. I believe there's set through 17 items, and the information that's in here is, if we want to look at a one-factor congeneric model, the first one I'm going to look at are the items which are supposed to be attentiveness. So for example, item 1 is about can concentrate on any task. Item 2 is eager to learn. 3 is perseveres in the face of difficulty. 10 is persistent. And 14 is purposeful activity. So to run this, I'll say SEM. Let me actually zoom in on this so you can see what I'm typing. And I'll screw it up a little bit. So I'm going to type in SEM. I'll call it attent. And attent influences Q1, Q2, Q3, Q10, and Q14. I'll just type each one of them separately.
Can we rename our Qs to make them?
You can. I forget exactly how to change the variable names right off the top of my head.
Okay.
But you're more than welcome to do that.
Yeah, they're just a little abstract.
I think it's part of the data editor.
Yep. Now again, I'm using the. Do you all have a copy of this sheet? It was the one. It has one factor congeneric measurement model at the top. This is the.
There we go.
I have two extra copies here. So Z. Right. All right. So I've got I've got one here. So all right.
Oh, so this is one scale.
So one instrument.
One instrument.
But it has 3 total scales on it. Okay. All right. So what we're going to do is, so I'm going to go ahead and run this. Go ahead and run that. And it will take a little bit of time, but it will do something eventually, I know. Okay.
Oh, so this is, I'm sorry to back up, but this is just like a revelation. So these variables are all single questions in a single instrument with subscales that have been designed so that there should be a reliability of sorts between those questions. And so we're just basically doing what some instruments just already have it in a CD basically for a scoring, where they take those questions and do a composite score.
Yep.
Okay. I thought they were all variables.
Well, they're variables in the sense that they're all measured.
Yeah.
They're all measured.
I thought each Q was an individual test.
No.
Aggregate.
No. just one item. And I think they're just coded 1 through 5, if I remember correctly.
Yeah.
All right, so what I want to do is, so I want to draw our attention first when we look at this model to the results, and then we're going to talk very briefly about those. So I need the number of observations, which is 2,062. So again, I'm just going to read through what's here. We have the code that we just ran, information for the endogenous variables. Remember, our measurement variables are always endogenous. The exogenous variables, let me rephrase that. The measurement variables for our latent constructs are always endogenous variables because they're always dependent variables. The exogenous variable is attention. It ran an iterative function a couple times to figure out what the best estimate was. It came up with what it thinks is the best estimate. It used maximum likelihood estimation, ML. And the number of data is 2062. And here are the pieces of information it gives us. It gives us the coefficient for Q1, Q3, Q2, Q3, Q10, and Q14. The standard error, a z-score, and a probability score. It gives us the... Oh, I'm sorry. I think I was reading off the intercepts there, not the loadings. 0.8, 0.9, 1.0, 0.85. And then it gives confidence intervals for where it thinks those values might actually be. So these are where it thinks the estimates are. Reports mine, if I hit the next hit, will give me the variance. I have the estimated variance for each of my items. And then I have the attention. And so if we can go back through this, I can actually count how many variables were estimated. It constrained the factor loading for Q1 to 1. We call that an anchor loading. And then it estimated 4 parameters. It estimated 5 item variances. So that takes us to 9. And it estimated the factor score variance. So that takes us to 10. But if we have 5 variables, 5 times 5 plus 1 is 6. 5 times 6 is 30. Divided by 2 is 15. So we had 15 equations coming from our covariance matrix. We had 10 parameters to be estimated. That left us with 5 degrees of freedom. And the chi-square test for that value was 182.74. 182.74. Now what I want to do is I want to try something because I'm trying to remember. No, I don't want to do this right now. I'll just stop here. So
what's the constant again? Is that the intercept?
That would essentially be the intercept. We're ignoring those for now. SEM instated defaults to actually calculating the constant. Surprisingly, most of the other programs, you actually have to go in and turn that on.
Right.
If you only gave it a covariance matrix, it can't calculate those, and it won't actually report those. Okay, so it turns out that we'll see that in the end we can, and they're extremely variable. So now the attention, you can't change that. The constant for attention is always 0. Okay. So we're going to focus right here for a second. Okay. So the chi-squared distribution with 5 degrees of freedom had a value of 182.74. The likelihood of seeing that value by chance is extremely rare. It's extremely rare. Now, the problem with this is how truly rare is it? Because if I scroll up, I notice that I have 2,000, over 2,000, almost 2,100 data points in this sample. So that's a lot of data. All right, and the key is I know that this is extremely sensitive. So I want to look at estat GoF, comma, stats all. Let me zoom in on that. Assuming I've done that correctly, that will give me the goodness of fit estimates, and it will actually report all of them. And I'll zoom back out a little bit so we can see them. And here is the information.
Can you do the command again? Because I got
Yep.
It's estat.
Comma, estat
the
GoF, comma, stats all. So the first thing it reports is the chi-square, the likelihood ratio test. It gives that information to us there. All right. Then it reports the RMSEA, and we see that we have an RMSEA of 0.131. We often call the RMSEA a badness of fit measure instead of a goodness of fit measure. And here's where it gets a little curious. The CFI and the TLI are 0.98 and 0.959. Now, oh, and then one more, the SRMR is 0.018. Let me see if I can scroll down a little bit. That's probably the end of this information. Okay. All right, so what we know, unfortunately,